Told you this was kind of a miscellaneous integration topics kind of a day. We're just kind of blending all of these things together and seeing how much we really understand it. So this is going to blend the second fundamental theorem as well as a function defined by an integral. So the question is pretty straightforward. It's not a lot of information. It just gives me the function that's defined by this integral here, and those are my limits of integration. And then it says, for what values of x is the graph of f decreasing? Well, I don't have a lot of information here, but I do know that my calculus brain tells me that f is decreasing when the derivative, or f prime, is negative. That's all based on my fun chart. So if I can find the derivative of this and figure out where that's negative, I'm going to be able to figure out where f is decreasing pretty straightforwardly. So the derivative of this, okay, that becomes the second fundamental theorem, where I don't want to manipulate this. I don't want to multiply this out. I don't want to have to FOIL anything. I don't want to do any of that. But if I'm doing the derivative of an integral, remember this isn't a chain rule because this is a straight x. I can take that x and I can place it in where the other variable was. So the derivative of f is f prime, and that's what I'm concerned with. So f prime of x is equal to, now just place here, this is the second fundamental theorem of calculus, x plus 2, and then x minus 3 squared. Now I want to know where that's equal to 0 so I can make a sign chart. Well, I like my factors. I don't want to multiply it all out. I can tell that this is going to be equal to 0 at x equals negative 2 and x equals 3. That's going to be where this is equal to 0. That's the derivative being equal to 0. So now let's use a sign chart. I always label my sign charts. I'm going to be at negative 2 and 3. And remember, I'm just plugging these numbers into the derivative to see where it's positive and negative. So if I plug in a negative 3, this is just a number line. A negative 3 in here, I get a negative number and a negative number, but it's a squared. So no matter what I plug in here, I'm going to get a positive out of this. So this is going to be a negative times a positive. So I'm going to have a negative derivative, which means the function is decreasing there. Then I'll move on to my next piece of my number line. So in between negative 2 and 3, so I'll use 0. So again, this is always going to be positive. So this is a positive times a positive. So there I'm increasing. And before I jump the gun here, I'm going to make sure I'm not going to just alternate these automatically. If I plug a 4 in here, I also get a positive and a positive. So this is what it looks like. That's my sign chart, saying that the derivative of f gives me this, which tells me that the function should be decreasing from negative infinity to negative 2. So I'll just write that out. Therefore, based on this sign chart, okay, f is decreasing from negative infinity to negative 2 because f prime is negative on that interval. Now, I have no idea what this graph of this integral looks like, but I do have an idea of what this looks like just based on the information in my sign chart. So let's take a look at that. If I were to just kind of sketch this graph, I know that my derivative is negative up until negative 2. So it's going to do here, it's going to go derivative negative. And then I know that I'm also looking at, this is a cubic function because I've got x and then x squared. So I know I've got a little bit of that feel to it. So I'm going to negative until negative 2. Sorry, let me make sure I put that on there here. And then I would be increasing. If you actually graphed that, you could see all of this. This is 1, 2, 3. It actually shoots up quite a bit. It goes back down to 3, and then it pops back up. So this is that cubic look. Alright, let me put this number here so you can see it. So you've got negative derivative, therefore the function is decreasing, and then it's positive the rest of the way, even though it does actually hit 0 at 3, it doesn't go to decreasing. It just levels off on a horizontal tangent and then increases again. Alright, so this is just kind of a visual for you to see, but that will give you the interval that will answer this question about where is the graph of f decreasing. It's decreasing from negative infinity to negative 2 because the derivative is negative on that interval.